Alright, part 2 of sequences in series. The first, this is an example straight out of the textbook. Alright, so a psychologist conducts an experiment, blah blah blah. Okay, day of test, 1, 2, 3, 4, number of words that this person can recall, 16 on the first day, 12 on the second day, etc. If the sequence continues this way, how many words will be recalled on the 7th day? So, you need to know, is it an AP or a GP? Is this an arithmetic or is it a GP? Okay, if it's arithmetic, it has to be the same. It has to be the same difference. So this is going -4 and then -3. Okay, it's going down 4 and down 3, so not an AP. Is the ratio, if it's to be a geometric progression, the ratio has to be the same. Okay, so that means that T2 over T1 has to equal T3 over T2, has to equal T4 over T3, etc. Okay, second term over first term. So 12 over 16, does that equal 9 over 12? And does that equal 6.75 over 9? And if you work it all out, these are all 0.75, so GP, it is a geometric progression. Geometric progression, Tn is A times R to the n take 1. A, first term, 16. R, common ratio, 0.75. So, 7th term, T of 7 equals AR to the 7 take 1 equals 16 times 0.75 to the power of 6, and calculator equals 2.85. So, roughly 3 words. Next topic is, it's in the same section, a recursive definition for a sequence of numbers. So if you look at this particular sequence, 2, 5, 11, 23, 47, it's not arithmetic, it's not geometric, but if you look closely, there is a pattern, and the pattern is, if you look at 2, if you double 2, you get 4. Not quite 5. If you double 5, you get 10. Okay, if you double 11, you get 22. So what's happening is you're doubling plus 1. Okay, 2 times 2 plus 1 is 5. 5 times 2 plus 1 is 11. Okay, doubling and plus 1. So this is neither a AP or GP, but the way to define this is to say that, okay, my n plus 1 term is twice the previous term, which is the Tn, and add 1 to that. Okay, but that formula isn't quite enough, because if we were just given that formula, we really need a starting point. Okay, you need to know, in order to calculate the next number, you need the previous number, so we need to be given at least one number. So really, we need the first number. I suppose you could go work backwards, but what generally happens is you're given the first number, T1 in this case. So, let's do example 2 here. If Tn plus 1 equals 3Tn minus 2, and T1 equals 4, list the first 5 numbers in this sequence. Okay, well, we know the first number is going to be 4. So the next number, times it by 3 and subtract 2. 3 times 4. Okay, 3 times 4 minus 2. 12 minus 2 is 10. 3 times 10 minus 2 is 28, and so on. Oh boy, what is this? 84, 82. Let's see, 244, I think. Anyway, so it goes on like that. And in your calculator, and doing a sum, there's not a formula for a sum, but I will show you if you wanted to do a sum, you can do all this on the graphics calculator. And yeah, your graphics calculator can give you a list of these, and it can give you a sum. There's a little trick to that. Let me show you how to do that. First off, just another, I could have written this definition like this. Okay, equals 2t of n minus 1 plus 1. Okay, this is the same thing. It's saying tn and then the previous tn minus 1. It's just that this is the format that the calculator uses rather than this format. So I just wanted to show you that. And alright, in your calculator, you need to change your mode. Normally everything is in function mode. That is parametric, that is polar. I think I haven't used that mode, but this is for sequences. Okay, if you use that, and now if you go into the y equals, everything changes. Alright, so un equals, this is this tn equals, okay? In this case, look, I'm doing this one here, I'm going to do this one. So I'm going to write tn equals 3 times tn take 1 minus 2. And on your calculator, instead of t, we use u, which is in blue here above the 7. Okay, so u, bracket. The n, just hit that button that you usually get x from. Okay, so, oops, and I need to have a 3 in front of that, 3 times that, so let's insert a 3, minus 1, minus 2. This 1 up the top, this n minimum, is basically, you pretty much always use 1, you could use something else. That's just saying that this is term number 1, term number 2, term number 3, and so on. You could start counting in another number. Okay, that's all that 1 is for. The minimum, this is your, in this case, my T1, my 4, is my UN min. Okay, so I want to make a 4 there. And I don't graph that. What I do is the blue table. It's the same graph button, but I have to do second. Table. And there it is. Oh, I can check if my calculations were correct. And wow, what do you know, they were. Alright, to do a sum, what I'm going to do, something a little bit tricky here, is I'm going to go back into this y equals, and so I can actually do another series here. Okay, let's see, how did I do this? I tried this before. I'm going to make this, you know, I could just put a different series in. Okay, just like, you know, you've got your y1, y2, and so on. But I'm going to use my minimum as 4. But what I'm going to do here is take, this is using the letter V, so I'm going to go into take my letter V above the 8. So my previous value, I'm going to do my n take 1. But then I'm going to add my, this un formula. I'm going to put this whole formula in, this 3 times u of n take 1 minus 2. So I'm starting with my first number, and I'm going to add, each time I'm going to add on the next number in that u sequence. And let's see what this does. Okay, so now I've got 4, and now I've got 14 for my next one. So that's given me the sum of the first two. I've got 42 for the third. So right, if I wanted the sum, if I had said here, list the first 5 and find sum of first 8, I would just go into my calculator here. Hopefully I can scroll down and see the 8th number. The sum is 9848. Okay, 9848. So the only way to do that, really, besides just listing out the numbers and adding them up, is to use a calculator. Okay, next example. This is this method of writing is another way to list a series. Okay, so this is a Greek letter sigma. In maths, it means sum. So this is saying, and usually this is very strange the way they've written this here, and I think it's just this book, but I would normally write r equals. Okay, so what this means, if I write something like this, r equals 3 to 5 r squared, this means I'm going to make r go from start at 3, just going up by 1 each time, to 5, and I'm going to make the sum of that. So I'm going to do 3, so if r is 3, then r squared is 3 squared. And I'm doing a sum, so the next number is 4, so I'm going to do 4 squared, and then I'm going to stop at 5. Alright, which is 50. 9 plus 16 plus 25 equals 50. So just to practice one like that, just try this one. Okay, evaluate, I'll just make something up. R equals 2 to 6 of 3r minus 4. Alright, so pause, give it a shot, and then I'll do the answer. Okay, you've paused, you've done it. Alright, so this is the sum. R equals, start with r equals 2, so we've got 3 times 2 minus 4 is 2. That's the first term. Okay, then we go to 3. 3 times 3 is 9 minus 4 is 5. And the next number, r, is 4, so 3 times 4 is 12 minus 4 is 8, and so on. And actually, in this case, we end up with a, what do you call it, arithmetic progression, which, if you remember, the other formula is first plus last, which is 16, times the number, which is 5, so that's 80 divided by 2, so that should be 40. Anyway, and you can also use formulas for that. Okay, this video is finished.